Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to see magnetic field due to finite current carrying conductor, and we will see the cases also related to this, and here we will also see how a finite current carrying conductor can be converted into a infinite or semi-infinite length of current carrying conductor by using some approximations. Okay, and at the end of learning all these concepts, we will solve multiple questions also to strengthen your concept. Okay students, so let's start the video. Is it? So here you can see very well what is the heading. You can see here, magnetic field due to a straight current carrying conductor of finite length. Okay, so let's go through it first. Let a straight thin conductor of finite length. See, thin conductor. Till the time in the question they are not telling anything, that means thin conductor. Okay, so thin conductor of finite length carries current I. Magnetic field due to this conductor at point P, which lies at a perpendicular distance r, always perpendicular distance r, okay, from the conductor is given by. Okay, so according to the introduction, what is there? There is the one conductor and it is carrying the current I. Okay, and let's take here point P is there, and at this point P I want to calculate the magnetic field, that means BP. Okay, and what is the perpendicular distance? The perpendicular distance is small r. All this basic learning is very important. Okay, after that, as this is the finite length conductor, this end is M, this end is N, and let's take here perpendicular distance is Q. Okay, after that what we'll do here, we will just connect this end of the conductor to the observation point, is it? And another end of the conductor also to the observation point here. Okay, like this it will be connected. Imaginary line is there. Okay, that's why we are drawing like this. After that, say here this angle. This angle you can see here, this is the clockwise angle. I have taken alpha. Direction also matters. And this side anti-clockwise, and here what is the angle? Let's take here beta. Okay, so remember that here when the current is flowing in upward direction, right hand palm rule we have to use. All the fingers along the current, palm towards the observation point P, then thumb is going in which direction? Inside. That means magnetic field at point P will be in a which direction? It will be inside of the board. And whenever inside of the board, remember that here this one will represent always minus K cap. Okay, similarly if the current is flowing in downward direction, then what will happen? That here, see, all my fingers downward, palm towards the observation point, then you can see thumb is coming outside. In this situation what will happen? That here dot will be there, and this one is called K cap. Minus K cap means along negative z direction, K cap means along positive z direction. Minus K cap is possible when the current is going upward, and plus K cap is possible when the current is going downward. Is it? So this basic should be clear. After that, remember that here actually the derivation is not important even for the CBSE, NEET, JEE, anywhere. Okay, for the basic, if you are interested to do the derivations and all, you can get in a book and all that, but derivation is not at all important. I'm just writing here the formula. So magnetic field at point P is given by, remember that here, mu naught I by 4 pi r. Okay, mu naught I by 4 pi r, and here we can write here sine alpha plus sine beta. Okay, this is the formula is there. Students, kindly remember this formula. The full video will revolve around this formula only. What is r? Remember that r is the perpendicular distance from the wire to the observation point here. Is it? Because anyhow this here, this r is written here. Now perpendicular distance, remember that here. And after that, if I talk about here, see, this angle is alpha, is it? So this angle alpha in which direction? Clockwise direction. So remember that here, when it is clockwise direction, then only it will be taken as negative, because remember that angle is a vector quantity. Okay, directions can be also there, anti-clockwise, clockwise. Now, so here, and if I talk about this beta, okay, so this beta, how we have taken here, this beta is the anti-clockwise. So whenever it is anti-clockwise, that time only we will take here positive to apply this formula. Okay, and you can see very well where alpha and beta are angles at the observation point of the conductor. Okay, at the observation point, that means at point P. Okay, remember that here. So this is the introduction of all this. And where is the alpha and beta? At the observation point. Again, I am telling you. Now students, after that, if we make from this formula one more formula that is also helpful to solve the questions, what will happen that here? Remember that here, if in case here I take this angle, for example, theta, okay, and here I take this angle phi, okay. So what will happen that here, if I, let's take here is the point is P is there now. So if I take the triangle, see here I will write here, so see, if I take the triangle PQM, which triangle I am taking here, students, PQM. So in triangle PQM, what will happen that here, you know, this is 90, so we can write here, see, 90 plus alpha plus theta equal to 180 degree. Again I am telling you, 90 plus alpha plus theta equal to 180 degree, because in a triangle sum of interior angles is a 180 degree. So from here, if I write here alpha, this alpha will be 90 minus theta, is it? So this is in a triangle. Similarly, if I talk about here the next triangle, let's take I have taken the triangle PQN. What is this here, students? PQN. So here what will happen that, remember that here, beta plus phi plus this 90 will be how much? 180 degree. So from there, if you will write here the beta, this beta will come here 90 minus phi, okay, and this alpha and beta I will replace here. So sine alpha means 90 minus theta, sine 90 minus theta, beta means 90 minus phi, so sine 90 minus phi, okay. So this alpha and beta angle I am going to replace in this formula, okay. How this will happen that here, see, so you know very well, again I am telling you here, as BP equal to mu naught I by 4 pi r, and I have told you sine alpha plus sine beta, is it? And depending upon the situation, as I am telling you now, so mu naught I by 4 pi r, and here alpha how much here, 90 minus theta, and beta how much here, you know, 90 minus phi, is it? 90 minus phi, is it? So after that, what will happen that here, this magnetic field at point P in another form is given by mu naught I by 4r, and you know sine 90 minus theta means cos theta, and sine 90 minus phi means cos phi here, okay. So here also you can see very well, we have got one more formula, is it? Before that, sine alpha plus sine beta, there alpha beta was the angle at the observation point. But here what is coming here, cos theta plus cos phi with this, and what is theta and phi here, where theta and phi are angles at ends M and N of the conductor. So whenever we are taking angles at the observation point, sine based formula. Whenever we are taking angle at the ends of the conductor, cos based formula, remember that here. And here you can see the magnetic field in which direction, inside. So whenever we write the answers, maybe we can write in a vector form, and here we can just write here cross inside based upon this, is it? And here also I can write here cross inside. This one indicates the direction. Instead of this, you can write minus k cap also, and here you have to put one vector sign, is it? So I hope so. This is very, very clear to you, is it? And this thing, can you remember that here? Alpha clockwise positive, beta anti-clockwise positive, okay. Now students, after that we are going to see some cases, because all these things we have learned, but we have to solve questions also, no? So to solve the questions, we should know all this. So see here, cases of magnetic field due to straight wire, okay. So see here, for infinite wire, you know very well, there is nothing like an infinite wire and all that. But what will happen that here, whenever this observation point P, that means where magnetic field is BP, is R and the length of the conductor is L. But what is happening that here, if R is less than R, that means observation point is very close to the conductor. Now, so what we can tell, R is less than R. There what will happen that here, you can see very well, alpha is this side. Now, so when the conductor you can see very far, this alpha will keep on increase, and for if the R is less than L, then what will happen that here, this one will keep on go like this, and alpha will be how much here? The alpha will be, just guess and tell me, alpha will be 90 degree. Infinite length conductor, alpha will be 90 degree. Similarly here also, this side, if we keep on increase like this, you can see beta also keep on increasing, and here beta will be how much here, students? This beta will be also how much? 90 degree, is it? And if we talk about here the magnetic field, anyhow in which direction? Inside, according to the right hand palm rule, is it? So students, if I write here the magnetic field, what this will come here? See, BP equal to mu naught I by 4 pi r. Now angle at the observation point, that means here this alpha is 90 degree and this side beta is also 90 degree, correct now? So what we can write here? See here, sine 90 plus sine 90. Sine 90, how much here? 1. So 1 plus 1, 2. And this 2 by 4, it will become 1 by 2. Is it? That means you can see very well, the magnetic field due to infinite wire will come here mu naught I by 2 pi r. Remember this. Is it? Due to which wire? Due to infinite wire. Even in the question, they are telling long straight conductor. By default, you have to always take which wire? This infinite wire. That means upward also infinite, downward also infinite. Now, so we will tell here infinite wire. Now students, after that, next one, if we talk about see the second A, here we are going to see the 3 cases. So now we are going to see second A, 2A. So here what is happening that here, let's take here observation point is this, the magnetic field BP is inside, which wire is there? For semi-infinite wire. That means upward up to infinite, but downward wire itself is not there. And remember that here, just in case of one end of the wire, only observation point is here. Okay, so here what will happen that here, this side alpha will be how much here? Anyhow 90 degree, but this side any angle is there? No angle. So beta will be how much here? 0 degree here. Okay, so remember that alpha 90 and beta 0. So in this situation what will happen that here, this magnetic field is given by mu naught I by 4 pi r. Sin alpha means sine 90 and beta, there is the no wire downward, so 0. Sine 90 is 1 and sine 0 is also 0, you know very well. That means what will come here? The magnetic field due to semi-infinite wire will come what here? Mu naught I by 4 pi r. By default, if they are just telling semi-infinite wire, they did not mention anything. That means always this situation, observation point is just in front of one of the end of the wire. This is the infinite wire, this is the semi-infinite wire. Okay, remember that here. After that, we will see further cases of semi-infinite wire also, but by default means case 2A only. Okay, now see again. For semi-infinite wire here, what is happening that here? R is less than L, as I have told you. So here what is happening that here, see the magnetic field is BP, this side wire is infinite, so anyhow alpha how much here? 90 degree, but this side you can see the wire is there like this, no? Like this. And here you can see this angle beta is there. This angle is what? Angle is anti-clockwise. So remember that here, when the angle is anti-clockwise, what is there? Plus beta. Why plus beta? Because angle is what? The angle is anti-clockwise. Is it? And alpha how much here? One side wire is infinite, so alpha is 90. So here if I write here the formula, what this will become here? See, BP equal to mu naught I by 4r sin alpha plus sin beta. Correct? So we can write here sine alpha means 90 plus sine of plus beta. Anyhow, is it? That means what this will come here, students? Remember that here mu naught I by 4 pi r, sine 90 means 1. So 1 plus sine beta in this situation. This will be the magnetic field at point P. Is it? So what is coming here, students? Mu naught I by 4 pi r, 1 plus sine beta. Is it? 2A case. After that, if we talk about here this case, here what is happening that here, from the point P we have drawn the perpendicular and the other end of the wire was down this line, no? Or we can tell down this point Q. But here what will happen that here, when see here, this end of the wire is there, na? This end of the wire, this is down, no, this is the up. Okay, so here what we have to do, if the wire is like this, from here we will draw here the one perpendicular like this. Now see, we'll extend the wire. No, we will just wire is up to this only, but we will just extend the wire by the dotted line. Okay, and here what is happening that here, this is the perpendicular Q. So here you can see another end of the wire is where? Down the point Q, but here and the end of the wire is above the point Q. Okay, so here what will happen that here, remember that here anyhow this side see up to the infinite only, so anyhow alpha is 90 degree only. Correct? No, alpha is 90 degree. Why? Because this side wire is up to infinite. But see here you can see BP, and see here if I will draw here the like this, now this end of the wire I will connect to the observation point. Then here this angle you can see this is the beta. What is this here, students? Beta. And now this beta in which directions here? This beta. This beta you can see very well. Now it is going clockwise. Here it was anti-clockwise, but now it is going which direction? Clockwise. So in this situation, what will happen that here? This I will take here minus beta, okay? And this minus beta is clockwise. So here what will happen that here, students? If I write here the magnetic field, remember that here mu naught I by 4 pi r. Here alpha is 90 because one end of the wire is up to infinite. You can say dotted line, correct now? Plus sine of minus beta, is it? Sine of minus beta. So what we can write here? Magnetic field at point P, it will come here mu naught I by 4 pi r 1 minus sine beta. What will come here, students? 1 minus sine beta. And anyhow, at all the places magnetic field is inside. So like this also I can do it here, is it? And even in previous situations also, no, magnetic field was inside. So adjacent to the formula, we can do like this is there, is it? So we have seen the infinite wire cases, semi-infinite wire, how many cases we have seen? The 3 cases, 2A, 2B, 2C, is it? And after that, next one we are going to see for finite wire. And here I have written 3B. Then where is 3A actually? Okay, so for the finite wire, remember that the 3A case is here. What is this here, students? This is the third A case. This is the third case. Now, this I told in the starting, general situation and all that. This is which case? Third A case. Now, is it? So third A is clear. Now after that, we are going to move for the third B. Now, so here what is happening that here? Kindly see the students. Now, this is the finite wire, no? And here anyhow the magnetic field is inside, is it? So here what will happen that here, see students, from this end of the wire, no? See here. Here what is this? This is the alpha. And beta how much here? 0. Why beta is 0? Because down this wire, not down to this point Q, any other wire is there? Wire is not there. So beta how much here? 0 degree. And this alpha is a positive. What is there, students? This alpha is plus alpha positive. Why? Because this in which direction? As I have told you, whenever alpha is anti-clockwise direction, it will be positive, is it? So in this situation, students, this magnetic field is given by what? Mu naught I by 4 pi r sine alpha plus sine beta means 0 degree here, is it? That means what it will come here? Remember that here, this BP will come here mu naught I by 4 pi r and just a sine alpha, is it? Remember that here, this formula. Now we are just seeing the cases and all that here, is it? Then so many questions we have to solve it. Now students, after that here, this situations here also what is this? This finite wire is there. Now, and here anyhow observation point P is there, magnetic field is anyhow inside. Again what we'll do here, from one end of the wire, from this end of the wire, we will extend the wire so that we can draw one perpendicular from the extended part of the wire to the observation point, is it? Now what will happen that here, see the students here, from the end of the wire, I will connect here. Now this angle you can see alpha, is it? And after that, see here, one more, if I will draw like this here, see. Again from the other end of the wire to the observation point, and this angle is what? Beta. Now you can see alpha in a same sense, alpha in a same sense, na? Plus alpha. Why? Because anyhow it is going in a which one? Like this, na? You can see it is going in a clockwise sense. Okay, so anyhow the clockwise sense, see, clockwise, just let me see it. Okay, see, this is the clockwise, na? So see, clockwise actually, clockwise, see, clockwise, correct now? So alpha clockwise, clockwise only, na? Because in the direction of the watch needle, is it? So here also alpha is the clockwise positive, is it? And beta, as I have told you students, when the beta is anti-clockwise, that time only positive, but now here beta also in which sense? Clockwise. So here what will happen that here, students, this will be minus beta. Why? Because this is in a which sense? This is also in a clockwise sense, because remember that here, students, this side it will be like this clockwise, and then like this it used to be anti-clockwise. Okay, if there is any confusion, because I also used to get confused sometimes. Okay, so like this here. So here what will happen that here, see, this BP is given here mu naught I by 4 pi r, and here sine plus alpha plus sine of minus beta, correct? That means what will come here, the students say, this BP will come here mu naught I by 4 pi r, and it will come here sine alpha minus sine beta, because sine is odd function, sine of minus beta will be minus sine beta. Okay, so these cases you have to remember that here: infinite wire 1 case, semi-infinite wire 3 cases, and again finite wire 3 case, and third A is at the starting. And as I have told you, alpha is clockwise positive and beta is anti-clockwise positive. Okay, so we will just check out also. Here also we have done correct only now. So you can see I told alpha clockwise positive, beta anti-clockwise positive. If it is going reverse means then you have to take it negative, is it? So students, with this we have covered just all the cases and all, is it? Now here onwards we are going to solve the question. Okay, so see here, very basic first question is there now. Pi ampere current is flowing through a long wire. Nothing is mentioned means which wire? Infinite wire. Due to this, a field of 5 into 10 power minus 5 Tesla produced. Then the distance of point from the axis of the wire is how much in millimeter. Okay, distance they told, but they did not tell which distance. That means always which distance here, students? Perpendicular distance. Let's take now. If I current direction not given na, so by default anyhow, whenever the by default used to be there na, by default current used to be in which direction? Like this, so that the magnetic field by default it should be always inside. Nothing is mentioned means by default you always you make the current direction in such a way so that the magnetic field should go inside. Okay, so here just see here what are the things are given here. See, the current is given here, students, pi ampere, is it? Pi ampere. After that the magnetic field how much is given here? See the students, 5 into 10 power minus 5 Tesla, and they are asking here the perpendicular distance r, is it? Very simple. So we know very well, no? We know the formula. Magnetic field due to infinite wire, what is the formula here, students? Mu naught I by 2 pi r. Remember that. Okay, by default infinite wire mu naught I by 2 pi r. Semi-infinite wire mu naught I by 4 pi r. Okay, great. So here what will happen that here, see this r will come here, see here, this mu naught I by 2 pi into Bp. Is it? Now just put the values please. Mu naught as it is. Okay. I how much is given here? I is the pi ampere, and here see here 2 pi into what is the value of the Bp? The value of Bp is 5 into 10 to the power minus 5. Is it? Now you can see the students say what are the things will cancel out. See, this pi and this pi cancel. So it will come here, see, mu naught by 5 into 2. 10 into 10 power minus 5 means it will come here 10 power minus 4, is it? That means it will come here 10 to the power 4 mu naught, and anyhow in a meter. Which option is correct here? 10 to the power 4 mu naught. And what is mu naught? Mu naught is called permeability of the free space, and remember that here, as I have told you before also, mu naught by 4 pi value is used to be 10 to the power minus 7 in SI unit, and in a previous video I told you, and mu naught by 4 pi value is 1 in a CGS unit. Okay, remember that here, all these things. Very basic question. Now, great. Now students, after that we'll move to the next question here. Very important question. Even in a CBSE sample paper and all, they have asked this kind of question. So see, two infinite length wire carries equal currents and placed along x-axis and y-axis respectively. You can see yellow color along x-axis, and this which color is there? Okay, pink color along y-axis. So see, at which points the resultant magnetic field is 0. Okay, even in a sample papers and all, they have asked at which points magnetic field is stronger inside, magnetic field is stronger outside. Okay, so we'll cover all the cases and all that. So students, for example, let's take here, I have taken, this is the wire 1. Now, so due to wire 1, what will happen that here? See, if in case my observation point is upward, that means A and B, you can see very well all the fingers along the current, palm towards the observation point upward, thumb is coming which side? Outside. That means due to wire 1, magnetic field at point A and B will be where? Outside. Is it? So here all the magnetic field I can't draw here, so I am drawing here. Now, so this is called here magnetic field due to which wire? Due to wire 1 at point A. Now, due to wire 1. Similarly here also what is happening that here? Magnetic field due to wire 1 now at point B. Now after that, see here students here. Now if I due to wire 1 only, if I see downward, see all the fingers along the current, palm towards the observation point downward, thumb is going which side? Inside. That means here what will happen that here, see the magnetic field due to wire 1 inside, and here also magnetic field due to wire 1 is inside. Is it? So now wire 1 work is completed. Now after that here we will go for wire 2. Now let's take this is the wire 2 is there. Is it? So again one by one see. Now my observation point will become A and D. Now all the fingers along the current upward, palm towards the observation point, thumb is going which side? Inside. That means due to wire 2 what will happen that here? This magnetic field will be where? This magnetic field will be inside. Is it? Now if I talk about this side here, see all the fingers along the current, palm towards the observation points, that means C and D. Thumb is coming which side? Outside. That means what will happen that here? See, magnetic field due to wire 2, and here also magnetic field due to wire 2. Now all these things are there. Now if I talk about here one by one, see here students, at point A, what is happening? You can see one magnetic field outside and then magnetic field inside. So both these magnetic fields at point A will cancel. Is it? So at point A, magnetic fields will cancel. Even I can write here, see, like this here, see, B1 plus B2 like this here. B1 how much here? Anyhow, infinite value is there, na, mu naught I by 2 pi r, but okay, I am just writing B, so I can write here, see, B1 means what will come here, see, Bk cap plus B2 means B minus K cap, both will cancel out. The magnetic field will be 0. Okay, if I talk about here, let's take next one here, at point B, is it? So at point B, what will happen that here, see, both the magnetic fields in which direction? Outward. No? So I can write here, see, B1 means Bk cap plus B2 is also Bk cap. What is coming here? 2Bk cap. Is it? Similarly, if I talk about here at point C, so at point C, what is happening that here? See, B1 is here inside. That means see, B minus K cap. See here, this is always vector B1 plus vector B2. Okay, and B2 is which direction? Outside. So again, see here, both will cancel out here. 0. Is it? After that, even if I take point D also, so BD, what will happen? See, both are in which direction? Inside. So what will happen that here? B minus K cap plus B minus K cap. What is coming here? See, B 2B minus K cap. Now what we can write here? We can write here 2B minus K cap here. Is it? And what is the value of the B? The value of B is mu naught I by 2 pi r only. Okay. Now they are asking where the magnetic field is 0 in the question. So see here, at point A, magnetic field is coming 0. Is it? And at point C also, magnetic field is coming 0. Is it? So here anyhow option is there, A comma C. Is it? But if I talk about point B, so you can see point B, the magnetic field is the strongest and outside. What is this? What I'm thinking that here, stronger and outside, or you can write strongest also. Okay, strongest and outside. Here what is happening that here also you can see the magnetic field is in strongest and where? Inside, because minus K is there, inside here, see, and here strongest and where? Outside is there. No? So they may ask anything, 0 magnetic field region, strongest outside, strongest inside, you can find out very easily. Is it? Great. Now students, we are going to see this question. Now, what is the question? Let's go to the question. See the students here. For the given current distribution, the magnetic field at point P is how much here? Okay. So point P is here. You can see this wire current 5 ampere, this wire current how much? 2.5 ampere, separated by 5 meter. Both are infinite wire. Okay. And here 2.5 meter distance. So remember that here, if I make here, this is wire 1, and if I make here, this is wire 2. Is it? So what this will happen that here, the students, due to wire 1, now all the fingers along the current, palm towards the observation point, thumb is going inside. Is it? So what will happen that here? Magnetic field at point P due to wire 1 is where? Due to wire 1 is inside. Is it? Similarly, if I talk about due to wire 2 also, you can see very well all the fingers along the current, palm towards the observation point P, thumb is coming outside. Now, so here I am writing here, see, this is outside, and here I can write here B2. Is it? So what will happen that here? Resultant magnetic field at point P means both in opposite direction, we have to subtract only. Is it? So first let me write here one by one, or okay, directly let's write here. So magnetic field at point P is given by what we can write here, B1 plus B2. Is it? B1 plus B2. Infinite wire formula, mu naught I by 2 pi r. Is it? So what we can write here, see, mu naught, and due to first wire current how much here? 5 ampere. So mu naught I by 2 pi. Is it? R how much is given? This perpendicular distance, it is given here 2.5. Is it? 2.5. In which direction? Inside. That means I'll write here minus K cap. Correct? Because see, inside. Plus B2 how much here? No? Due to wire 2. Again see here mu naught, and here 2.5 by 2 pi, na? Infinite wire, na? 2 pi, and again here how much is this? 2.5, is it? Because this distance, this is 2.5, total is 5, so this is also how much here? 2.5 only, and this is outside, that means I'll write here the k cap, is it? So now students, if I write here, if I'll simplify this, say 5 by 2.5 means 2, so I can write here, say mu naught by 2 pi, and here I can 5 by 2.5 means 2, is it? So this will come here 2 minus k cap plus again here mu naught by 2 pi, 2.5 by 2.5, 1, is it? And here what is coming here? K cap, okay? After that, students, let's take here, I have taken mu naught by 2 pi minus k cap common. So minus k cap common means here 2, and here k cap was there, so anyhow we have to write here minus 1. So what it will come here? Kindly see the students, mu naught by 2 pi, is it? Mu naught by 2 pi, mu naught by 2 pi minus k cap. And 2 minus 1 will become 1. And minus k cap means cross, inside, magnetic field inside. So mu naught by 2 pi is coming where? This is the correct option. And this one is representing minus k cap here. Is it? So see, in how much beautiful way we have calculated the magnetic field here. In this situation, magnetic field will be 0 extra. So if here also let's take, if in both the wires current is equal, maybe both the wires 5 ampere, both the wires 2.5 ampere, then only magnetic field will be 0. Okay, right. Now students, let's see the next question here. The question is what? See, for given current distribution, each infinite length wire produces magnetic field B at origin. Then resultant magnetic field at origin how much? What is the value of the B? Value of B is mu naught I by 2 pi A only, because wire is here, observation point is here A. So B value how much here? Actually it is not required, but I am still writing for you. Mu naught I by 2 pi A, is it? Now we will number the wires. No? So let number the wires. Let's take this is wire 1, this is wire 2, this is wire 3, and this is wire 4. No? And this is not a magnetic field now. Now this is the current here. Okay. So what we'll do here? One by one we'll write for the wire. Okay. So see here, magnetic field at point O due to wire 1. Is it? So see here, the current is coming which direction? Inside. When the current is going inside, see, all the fingers along the current palm. Now we are, what we are doing? Right hand palm rule. What is we are doing here? Now all the fingers along the current. Current is going inside. Palm towards the observation point. Thumb is going this side. This side. That means anyhow remember that here magnetic field in this direction. Na? B naught 1. So what we can write here? Remember that here this will become here B I cap. Okay. Now after that, if I write for the wire 2. B naught 2, no? So this is the wire B naught 2. Here what is happening that here again you see current inside, observation point is O, thumb is going where? Upward. That means due to wire 2, what will happen that here? This is, we can write here this is the B naught 2, is it? And we can write here, see, upward means along y axis means J cap unit vector. No? Similarly after that here, if I write for the wire 3, is it? So wire 3, what will happen that here, see students? Wire 3 is where? Wire 3 is here, is it? And here the current is coming outside. Okay, so remember that here when the current is coming outside, observation point is downward. See, my thumb is again going this side here, is it? So here again, what will happen that here? This will come B naught 3, is it? And what will come here? Again, students, B I cap. Now you guess for B naught 4 even. No? See this one here. Again, you can see current is coming outside, out of the board, dot inside the circle. So see all my fingers outside. Palm is towards point 2. Thumb is going where? Upward. Is it? That means here also, like this it will come here. We can write here B naught 4. Is it? So B naught 4 is also how much here? BJ cap. Is it? So if I write here, the students, the resultant magnetic field at point O means B naught 1 plus B naught 2 plus B naught 3 plus B naught 4. So when you will do here, 2BI cap plus 2BJ cap here. Even I can draw like this. You see, this side 2B, B and B will add. This side also 2B. We'll make here the one parallelogram, and this side resultant will come, how much it will come here? 2 by root 2. How it will come here? Because if I write here the magnitude, so magnitude means square root of coefficient of I cap square plus square root of coefficient of J cap square. When we'll simplify this, anyhow it will come here 2 by root 2. Is it? So where is the option? 2 by root 2? Yes, option C is the answer. Is it? We are just seeing here the very important kind of questions. Now students, let's see. This question is here. Question is like this. This is also semi-infinite wire case, but little bit twisted. So see here, the question is what? Asked in a NEET 2014. See, a long conducting wire carrying a current is bent at 120 degree, na? 120 degree, see figure. Now see, the magnetic field B at point P, the magnetic field B at point P on the right bisector of bending angle at a distance D from the bend is how much here, okay? Bend is here. Now my observation point is here. Anyhow, the magnetic field in which direction you can see here? All the fingers along the current, palm towards the observation point inside. Here also you can see here. All the fingers along the current, palm towards the observation point, see inside. So here anyhow, direction no confusion, the magnetic field is inside. But here, remember that here we will make the sections. So see here, let's take this is the section 1, because here calculating magnetic field is easy, horizontal wire. This is section 2, okay? And after that, what will happen that here, see here 120 degree they are telling that here, but let's take for example, this line is the angle bisector, this is theta, this is theta. So if we are solving for any general angle, and later what we can do here, we can see the students here 2 theta equal to 120 degree. So theta what will come here, 60 degree, no? So first we will solve for any general angle theta, later we will put the angle 60 degree, okay? Even if in case some other angle is there, so there also you can use the formula, okay? Great. So now students, after that what will happen that here, we are going to use the formula. Theta how much here, 60 degree. From point P you draw here the perpendicular, is it? So you know very well, this is D, this is theta. So this will be how much here, D sine theta. Perpendicular distance how much here, D sine theta, okay? And observation point is where? The observation point is at the end of the wire. I told you M and N. So let's take here, this is M. And this N is very far. So when N is very far, what will happen that here? It will become semi-infinite wire. Normally beta used to be, alpha beta used to be 90 degree and all. No? Like if whenever one side of the wire is infinite, so alpha or beta whatever 90 degree. But whenever we are writing in terms of cos, so this phi will be how much here? 0 degree here. Because sin 90, 1. Cos 0, 1. Okay, so whenever we are dealing in terms of cos, this phi will become 0 degree, na? Because see, this length will keep on like this. So what will happen that here? Phi will become 0 degree here, okay? And here anyhow, theta how much here? Theta we know 60 degree, is it? So for section 1, we are going to calculate magnetic field. So see here, students, so B not 1 or BP1? BP1, okay? What is the formula? Again I'm writing, see, mu naught I by 4 pi r, and the formula is cos theta plus cos phi. Where is the angle? Where is angle at the end points? Okay, so see here, what can I write here? See the students, mu naught I by 4 pi. What is the r? This perpendicular distance. How much here, students? Here, d sine theta. What is here? D sine theta. D sine theta. Okay, into cos theta. No? Cos theta plus cos theta plus cos 0. Cos 0 how much here? 1. Is it? So this thing is there. Now students, after that, if I just put the values also, so mu naught I by anyhow this is 4 pi d, no, d theta. Theta value how much is given here? Theta is 60 degree. So theta 60 degree means, sine 60 means, remember that here the students say root 3 by 2 into, and here what we can write here? Cos theta, cos 60. Cos 60 how much here students here? Half. Cos 60 half only, correct now? Plus 1, is it? So like this it is coming here. Now students, after that here, now we have to just simplify this here. So when I will simplify this, what it will come here? See here, this 2 2 is 4, okay? This 2 2 is 4 will come here, no? 2 2 is 4. 1 by 2 plus 1, that means it will become here 3 by 2. That means it will come here, see, 3 mu naught I, 3 mu naught I, here 3 by 2. This 2 and this 2 will adjust here. So 4 pi d. Now this is due to, what is this here students? This is due to one wire, is it? Correct now? We are going correct only. 2 2 is 4. Here 2 will come, 3 by 2, no? So 2 2 is 4, 4 pi d, and this root 3 is also there here. Is it? This root 3. See, this root 3 is there, no? So what will happen here students? This 3 by root 3 means we can write here, see, root 3 mu naught I by 4 pi d. This is due to one section. But if I talk about the section, second section also, this section also same story will be there, okay? So what will happen right here? If I write here the resultant magnetic field at point P, it will be BP1 plus BP2. BP1 is also same, BP2 also by symmetry it will be same only. So what this will become here? Due to two sections, it will become here 2 times of BP1, okay? So 2 times of BP1, again 2 times of root 3 mu naught I by 4 pi d. So 2 times means, so it will become 2 by 4. 2 by 4 means 1 by 2, is it? So see, again writing, see, 2 into root 3 mu naught I by 4 pi d, is it? And what will happen here? It will become here 2 2 is 4. So we can write as root 3 mu naught I by 2 pi d. Na? Root 3 mu naught I by 2 pi d. Even in which direction anyhow the magnetic field is inside also, is it? When we are doing this kind of symbol, no need to put your vector sign. When you are writing minus k cap, then only have to put the vector sign, okay? So kindly check the option here, students. The correct option is here, option D is the answer. Even if some other different theta angle is there, you can solve it, okay? Great. Now students, let's move for the this cases here. This is the questions, very directly. Even sometimes they used to ask directly, you should remember the formula, okay? So see here, even I remember the formula for this kind of situations. It will come option C. Remember it, 9 by 2 mu naught I by pi a. But I will tell you how it will come. Okay, so see here, magnetic field at the center of equilateral triangle, current carrying loop of side A and current out I how much here. Okay, and these 4 options are there. Okay, so anyhow we have to make here the sections. So see here, section 1, section 2, section 3. Okay, all the sections will be identical with respect to point O. We will just calculate for one section, then we will just multiply with 3. Okay, great. So let's take here which is the easy section. Let's take here section 1. So what is happening that you see the students here, I will draw here the one perpendicular here, and let's take here this is point M, and you know very well. Okay, let's first talk about this perpendicular distance, because we want this distance OM. Now OM is the only R from the wire to the observation point perpendicular distance. Okay, and let's take here students, this is A, anyhow let's take this is B, this is C. Now, so you know very well students here, if I talk about here, see, if I take here, see here, if I talk about this triangle, okay, this triangle if I talk about here, this is A, this is B, this is M. Now, so what is AB? A, I am telling the basic, this is A, that means this length how much here? A by 2. So if you will use the Pythagoras theorem, what will come here? It will come here root 3a by 2 is square root of a square minus a by 2 whole square, Pythagoras theorem. So it will come here root 3a by 2. After that, remember that here, students, after that, remember that here. Okay, this thing also we are doing here. Another method is also there to do it. Okay, I'll tell you that method. That will be the more easy. Okay, I'll just do that method. That method will be more easy. Okay, this no need. This no need here. Now I'll tell you easy method actually. Okay, so see here, what is the easy method? See here, easy method. See, this total angle is 60 degree. So see, this is 30 degree. This total angle is also 60 degree. So this is also how much here? 30 degree. Correct. Now if you see the triangle, very easy. I'm telling you. If you see the triangle OMB, so in triangle OMB, what will happen? That here, kindly see here, this OM, this OM by BM. This OM by BM will come what here? OM is the perpendicular, BM is the adjacent. So perpendicular by adjacent, opposite by adjacent is a tan 30. Easy we are doing here. So here now what is the OM? This OM will come here, BM tan 30. BM how much here? Total is A. So this is how much here? A by 2, is it? So A by 2 tan 30 1 by root 3, it will come here A by 2 root 3. Okay, this is the easiest way here. So what we have got here? OM we have got here A by 2 root 3, and this is only R. So perpendicular distance work is done. Now students, after that here, this angle is anyhow theta. At the end of the wire, this angle is phi, is it? So what will happen that here, students? See, the resultant magnetic field at point O due to wire 1, due to section 1 is given by formula. See, mu naught I by, what is the formula? 4 pi R, mu naught I by 4 pi R. Formula should be remembered, A by 2 root 3 into cos theta plus cos phi. Okay, cos theta plus cos phi. So cos 30 root 3 by 2. Again cos phi, that means cos 30 root 3 by 2. Correct? Correct only. So what this will happen that here, students? See, we can see here. See, we have to do the calculation. 2 2 is 4. Root 3 will go up, so it will become here, see, root 3 mu naught I by, we can tell here, see, 2 pi a, root 3 will go up, root 3 mu naught I by 2 pi a, and again you see root 3 by 2 plus root 3 by 2, how much here? Root 3. So what is coming here? See, 3 mu naught I by 2 pi a. But this is due to only one section. Okay, so if I write here the resultant magnetic field here, how many sections are there? Like this, second section, third section. So we have to just multiply with 3. So 3 times of B naught 1 you multiply 3 times, it will come here 9 mu naught I by 2 pi a, is it? And anyhow, direction, you can see here, na, current is which direction now? Current is the clockwise direction. Oh, again confusion comes here, na. So what will happen that here? Yes, this is the anti-clockwise direction. So see here, all the fingers along the current, palm towards the observation point. Now the magnetic field is outside here. So outside means a dot inside the circle here. Okay. So anyhow, option C is there. Na? This is the basic. Remember that here for the triangle. Is it? Great. Now students, after that, if we talk about here for square, even for square also, remember the formula. It will come 2 root 2 mu naught I by pi a. Na? Remember it directly because it will come in exam. Now here also what will happen that we will make the section 1, section 2, section 3 and here section 4. 4 sections we have made it, and after that we are going to do here the perpendicular distance, no? OM. Now calculating the perpendicular distance is easy. Why? Because this is A. So this length how much here? R equal to A by 2. Is it? Now this angle 45 degree. This angle also how much here? 45 degree. Is it? So what is happening that here? Remember that here even this is again theta and this is here phi. Okay. So again the formula BP equal to, see here, mu naught I by 4 pi. R value how much here? You know very well. A by 2 and cos 45, cos theta plus cos phi, because where is the angles at the end points M and N, na, cos theta plus cos phi. So we can write here, see the students here, 1 by root 2 plus 1 by root 2, is it? So what this will happen that here, we'll just cancel out here, see, 2 2 is 4, so it will become here, see the students here, mu naught I by, it will become here 2 pi a, is it? Mu naught I by 2 pi a, is it? And 1 by root 2 plus 1 by root 2, what will become here? 2 by root 2. And 2 by root 2 means we can write here root 2, is it? Now this thing is done. Now like that students, observation point O actually. So like that, how many sections are there? 4 sections are there now. So we have to multiply with a 4. So to become here, see the students here, 4 and 4 B naught 1. So 4 times means what this will become here, students, see, 4 by 2, 4 by 2, see I write here 4 mu naught I root 2 by 2 pi a. So it will become here what? 2 2 is 4. So see, 2 root 2 mu naught I by pi a, is it? And again magnetic field in which direction? See, I am using the right hand palm rule. Now you are very intelligent. Dot inside the circle. Correct option is here. Option A is the answer. Is it? Great. Now students, after that here we are seeing triangle, square. Now we will see here hexagon also. Okay. So see, magnetic field at the center of a regular hexagon, current carrying loop of side length A and current I is how much here? Okay. Here actually I did not write the options, no, but that answer also you should remember that here. Okay. So see here students, here how many sections will be there? See, see here, see, I will make here section 1, section 2, section 3, section 4, section 5, section C, like this. Okay. Now which section is easy? Anyhow this section I am going to take here. Remember that here in a regular hexagon there will be 6 equilateral triangles, no? So this is observation point O and see here the students, is it? And here you remember that here this is the A, na, and this is M. So as I have told you in the starting of the Pythagoras theorem, this perpendicular distance R will be how much here? Root 3a by 2 by using the Pythagoras theorem. This angle how much here? Anyhow 60 degree. This angle how much here? 60 degree. Okay. So one angle theta 60 degree, one angle phi 60 degree. Is it? So if I write here the magnetic field at point O due to section 1, it is given by, see here, mu naught I by again 4 pi R value what is given here? See, root 3a by 2. Correct na? Root 3a by 2. No? Equilateral triangle. And after that here cos theta plus cos phi. So it will come here cos 60 plus cos 60 now. Is it? Cos 60 plus cos 60 now. Cos 60 1 by 2. Again cos 60 1 by 2. 1 by 2 plus 1 by 2 1. So this overall will become 1. No? So what this will happen that here students? This will become here, see, mu naught I by this 2 2 is 4. So we can write here 2 root 3 pi a. Correct? Mu naught I by anyhow 2 2 is 4, so 2 root 3 pi a. Now students, if I write here the resultant magnetic field at point 2, due to how many sections here? 6 sections are there. Okay. So we can write here, see, 6 of B naught 1. Is it? 6 times of B naught 1. So students, it will become here, see, this 6 mu naught I by 2 times root 3 pi a. Is it? So what will happen that here? See, this will become here 2 3 is 6, 3 by root 3. 3 by root 3 means root 3. So it will become here, see, root 3 mu naught I by pi a. Is it? I hope so. Calculations and all is very, very perfect and all. Na? Can you remember that here? Root 3 mu naught I by pi a. Okay, great. Now students, after that, na, you have written all these things here. I am just checking one time, everything is okay, huh? Because options are not here. Na? If calculations, only calculations problem may happen, otherwise all are correct only here. Okay, this root 3 mu naught I by pi a. In which direction magnetic field here? Again, anyhow, see all the currents like this. Now anti-clockwise. Magnetic field is the outside only. Is it? Great. Now students, see here, if this kind of question is coming here, now the last kind of question we are seeing here. So see here, the magnetic field at the center of square of side A is how much here? Okay. So remember that here, if both the sides of the wire is having the different resistances, that time some magnetic field will be there. Same resistance means magnetic field will be 0. That we will see it. Okay. From that, whatever we are going to do now, from there we'll make some special case. Okay. So what is happening? Let's say, see, from here current I is coming here. Here it will go I1, and this side what will happen? That is students, this side current will go I2. Is it? I1, I2 we can calculate by the current divider theorem also, but first we are going to see. No? So let's take a students here. This is section 1 and this is section 2. Okay. And here also anyhow the current will go like this here, I1. Now, so here what will happen that here students, again if I write here, see, just make like this here. First I am going to do for this wire I am going to do here, na, this wire. So students, remember that here, na, from the wire I will draw here the one perpendicular. This R was how much here? Anyhow A by 2. Now this angle was how much here? 45 degree. This angle was also how much here? 45 degree. Is it? So if I write here the magnetic field at point O due to section 1, like that, how many wires are there? This wire, that means 2 times. 2 times, is it? This one I will do, but 2 times, because this wire and this wire. Okay, so 2 times. Again formula, mu naught I by 4 pi r cos theta plus cos phi. So see, mu naught I by, it will become here, current is I1, na? So mu naught I1, current is I1 here, so mu naught I1 by 4 pi A by 2 cos 45 plus cos 45, we know 1 by root 2 plus 1 by root 2, it will become 2 by root 2, and we can write here root 2. Is it? So from here, students, when you will simplify this here, see, this 2 2 is 4, is it? 2 2 is 4 here, no? 2 2 is 4, and anyhow students, this 2 and this 2 is also cancelled. Is it? So what we can write here, see, mu naught I1 root 2 by pi A. Is it? Mu naught I1 root 2 by pi A. All are correct only. Is it? A by 2. 2 2 is 4. 2 2 cancel. Mu naught I1 root 2 by pi A. Is it? Now, similarly students here, if I write for the section 2, here magnetic field in which direction? See here students here, the magnetic field is inside. Okay. So here we can write here the minus k cap here. Now, minus k cap. Now here, if we write due to the section 2, here also some symmetry will be there. Okay, symmetry. But current here, how much here? I2. So we can write here, see, mu naught I2 root 2 by pi A. By the symmetry itself we can write here, na? The way we have done here, same way will be applicable here also. Okay. And here the magnetic field in which direction? You can see very well students here, like this here, like this. So magnetic field will be outside. See, all the fingers along the current, palm towards the observation point outside. So what will come here students here? This will come here k cap. No? Now students, after that here, if I write here the resultant magnetic field. So resultant magnetic field, what will come here? Students, if I will just take here the common things and also see, mu naught root 2 by pi A minus k cap I have taken common. Is it? So minus k cap common means it will come here I1 minus I2. Is it? I1 minus I2. Now students, I1 how much here? I1 means we have to use here the current divider theorem. What current divider theorem tells that here? Remember that here students here, like this. Now, so if in case current I is coming here, resistance R1, here R2, this current I1, this current I2. So what is I1? I1 means R2 by R1 plus R2 into I. And what is I2? I2 means R1 by R1 plus R2 into I. Now see, I am just writing one for you. I1 means R2 by R1 plus R2 into I, like this here. Okay. So if I write here the I1 means which resistance we have to take? This side of resistance. 2R and 2R how much here? 4R. Total resistance how much here? 4R plus 2R, 6R into I. Is it? So I1 will come what here students here? When you will simplify this, 2 2 is 4, 2 3 is 6. I1 will come here. I1 is coming here 2I by 3. I1 is coming here 2I by 3. Correct now? 4r by 6, 2 2 is 4, 2 3 is 6, 2i by 3. Then I2, what will be the I2? I2 will be this side. I is coming, 2i by 3 went this side. So this side what will go here, students here? This will go here, I by 3, is it? So anyhow, you can just put the value. I1 is 2i by 3, I2 is I by 3. Then what this will come here, students? It will come here mu naught root 2 by pi a minus k cap, and here it will come here 2i by 3 minus I by 3 means anyhow I by 3. Okay, and the magnetic field in which direction? Anyhow we can write a minus k cap or cross inside the circle. Why the magnetic field is coming non-zero? Because this side of resistance, see, R and R, and this side of resistance 2R and 2R, both the sections resistances are different. Okay, that's why it is coming like this. Okay, if in case we talk about this situation here, na, special case. So in case of special case, what will happen that here, see, this side of, see, current I is coming here, so I1 will come what here, anyhow, this side resistance 2R, this side also resistance 2R, so path is same, that means I1 will come I by 2, even I2 will also come here, students, I by 2, now, remember that, you see, I1 is coming here, I by 2, I2 is going here, how much here, I by 2, is it? And if I talk about here the magnetic field at point O was how much here? What was the formula? See, this was the formula. Mu naught root 2 by pi a. See, it was there. Mu naught root 2 by pi a minus k cap. I1 minus I2. Is it? I1 minus I2 minus k cap. Anyhow, we have written it. Is it? No? So, as you know, I1 equal to I2. No? Both the paths are identical. No? I1 equal to I2 only. That means from here, whenever the paths are identical, magnetic field will how much here? Magnetic field will be 0. Is it? Even this thing is applicable this kind of situation also. Now, in our previous videos I have covered here. Let's take current I is going here. Current I is going here. Is it? And here how much current here? I by 2. Here also how much current is there? I by 2. Okay. And if I take here at point O, so by, as I have told you very well, na, due to this, see, due to section 1, magnetic field 0, you are intelligent, you know very well. Now, current carrying conductor is along the observation point. Due to section 2 also, magnetic field is 0. Due to this section 3, the magnetic field is inside. And due to this section, magnetic field is outside. Okay. So, if I write here, magnetic field at O will be again how much here? 0. Why? Because due to section 1, 0. Due to section 2 also, 0. Due to section 3, what will come here? Formula, due to semicircular coil, mu naught I by 4R, okay, but current is how much here? Mu naught I by 2 and here 4R, now resistance is R. In which direction? Inside minus k cap plus. Here, magnetic field will be outside, so see here, mu naught I by 2 by 4R, it will come here plus k cap, okay. And here what will happen that here, students, here, when you will simplify this, it will come 0. That I want to tell you, okay. And one more case is there, this case is there. Here also, when you will simplify this here, even in this case also, just remember that here, students, here, when you will do here I1 and here you will do here I2. No? Here I2, here I2. So what will happen that here, students, remember that here, you have to apply current divider theorem and all that. And when you will simplify this, you know what will happen that here, students, when you will solve this here, one formula will come. Is it? That formula I am just writing here. Is it? This is the formula. No? This thing should come here, see. Mu naught root 2 by 2 pi a, is it? And it will come here I1 minus 3 I2 and here it will come here minus k cap, is it? And when you will use the current divider theorem, you know what will happen that here, students, this I1 will come here 3I by 4, okay, and this I2 is here, na? This I2 will come here I by 4 by using current divider theorem, okay. So I1 will come 3I by 4, I2 will come 3 into I by 4. So again both of them will cancel out, okay. And what will come here, students, here also magnetic field will come here 0, okay. So what I am telling you, whatever cases I have told you, because directly they used to ask. Here also, if both the paths are identical, magnetic field is 0. Otherwise, by current divider theorem, you have to calculate the current. Okay. Here also, anyhow, both the sides path identical 0. Even in this situation also, see, square is there. This R, this R, this R, this R. So here also, when you will simplify and all that, what will happen here? The magnetic field will also come 0. Is it? Kindly see very well. So students, I hope so. This video based upon the finite wire, semi-infinite wire, and questions based upon this is very, very clear to you. Keep studying, keep growing.